In this video, we are going to learn how to calibrate 5 mm scanning probe in the RDMIS, Rational DMIS. This we have 5 mm by 20 mm length probe size, and we are going to calibrate at 0 angle, 0 rotation. So this is what we are going to do. Well, first of all, we have to right click on the desired angle and rotation. Then keep your probe near to the master sphere. We have 30 mm master sphere that we are going to use for calibrating. So this is how you can see on our left screen. The probe reached near to the calibration sphere. Yes, it started. Touch the first point, the next point, and you will see it will going to take almost 7.1 minute for scanning and as well as calibrating. So right now we are calibrating A0 B0, right? This is the calibration report. We can see at first row there is a A0 B0 we had calibrated on 7th March, right? Well, you can see on our left screen we have a perfect. On the screen you also see there is a X which is continuously X and Y continuously changing, right? Now we are into heading towards the tools. This is the machine where we can see a graphic or animation. The probe was scanning the sphere. This is the environment that we had created for our machinery setups. So there are shortcuts on this right screen display. Setup machines. We have a tool selected 5 by 20 mm scanning probe. We have a component calibration parts, their equipment group as well as racks. We have two rack, one rack, two rack. First rack was using for scanning probe, second was used for touch and trigger. So you can see in this display on the right side below near to the toolbar X, Y and Z, those are continuously frequently changes, correct? But A is a 0, B is a 0 near to the Renishaw brand logo. It's actually UK, United Kingdom. So this is how we are going to calibrate this sphere so we can get actual form error of the form error of the probe. How much it was wear, is it capable for getting reading near to the accurate. So this is how we are going to identify. Let's scroll to the right side so we can see. Yes, now you can see there is a 5.0065 mm reading. of a 5 mm by 20 mm length probe. This was the latest reading, and the palm error was a 6 micron. So we have a different angle with a different rotation that we are going to use for our programming or part inspection purposes. That's why we have record, right? We have, see, this video was recorded on 14 March. That's why it's updated. Now we are going to change this. Click on the right click, okay, 90. We are going to use 90 180. Right click on it, and then we have to calibrate. So you can see now it's moves towards the calibration sphere, and it will going to record. It will going to calibrate. Calibration is nothing but the actual size of a probe and stylus, which was we are cross verifying that it is a within tolerance or not, or it is a capable for inspecting parts on the CMM. That's the simple basic thing. We are using a Ruby material for Stylus Tip. Well, now you can see X, Y, Z with A 90 degree and B 180 degree below the BZ. It means your machine status shows the BZ one. Now we are going to see on our left screen is 90 180. Machine, and you can see animation where the scanning was doing in a clockwise and anti-clockwise direction. Our calibration is completed, angle 90 and rotation B180. So we have a latest reading 5.0036. This is the probe diameter and variation is up to 6 micron. So this is how you are going to calibrate your probe stylus tip. So our result should be match or near to the accurate. So this is the simple method that we are going to use for calibration. Remember, while calibrating your probe, you have to keep maximum speed of your machine, right? Otherwise it will going to show a error message. Like, subscribe, and if you have any doubt or any questions, comment me.